Hello everyone, welcome back to our BGP 4.0 hands-on. In the previous episode or demonstration, we saw how we can go ahead and influence the BGP route selection. And one of the mechanisms we learned was with the help of wait. Continuing in the same discussion, now we'll go ahead and learn another attribute that we can go ahead and play around or really go ahead and configure to influence again, some of the route selection. The another attribute that we plan to do demonstration is called local preference. And the local preference, before we really do a hands-on, there is one thing, I'm sure if you know how the BGP route selection works, that's good. If not, the decision when the BGP route selection works, it is going to prefer the external routes over the internal route. That means it will go ahead and prefer an eBGP path over your iBGP path. With that keeping in mind, let's go ahead and take a look at, for this demonstration, let's go to our, before I go ahead and switch it to the router R2, for this demonstration, I had to expand the topology a little bit. So here is the topology that I'm planning to use for this demonstration. So for this demonstration, this was the original topology that we were using where we had a router R2 that was connected with our 2 of ISPs. Now I went ahead and added one more router within your AS1, which we're calling a router R1. The router R1 has an eBGP session with the ISP1. Also, the router R1 has an iBGP session with the router R2. And these are the existing connection where R2 was connected with ISP1 and ISP2. So we continue to have that connection. Now, with the help of R1, we added few more links or, the few more ways for an IP prefix to get propagated. So keeping in this topology in mind, again, the router R1, the neighbor IP that we are using for the BGP relationship or BGP neighbor, it's 12.1. R2 has always been 12.2. Again, ISP1 is 12.11 and this is 20.20. So this is the topology that we are planning to go ahead and use. Now let's go ahead and switch it to our router R2. And on our router R2, let's go ahead and take a look at our BGP table. So I'll go ahead and say show IP BGP. Now in this table, if you take a look at, there are quite a few prefixes, and for some of the prefix, if you just pay an attention, let's pick one of the prefix for our discussion. Let's go ahead and select this prefix. So if you take a look at the prefix, which is 10.01.0/28. In front of this prefix, we have an I. Again, if you recall, I really stands for an internal route. That means this router R2 is learning this prefix from 12.11. And if you remember, 12.11 is our router R1. So it is learning this prefix from the router R1. Again, the metric in MED is 0. The local preference for this particular prefix is 100. And we have not changed any weight, so we have left the weight to default. So you could see it's a 0. And again, we could see the different path it is traversing. We are also getting the same prefix as reachable from 12.11. 12.11 is our ISP1 router. And at the moment, this is our valid path particularly. So that means if you take a look at these prefixes, this particular prefix, even though we are learning both, so this is we are learning from eBGP, and this is we are kind of learning from iBGP here at the moment. So we could clearly see that, okay, hey, there are multiple paths to reach this particular prefix. Again, if you remember, if you do the show IP BGP for this prefix, you could see all those paths. Let's go ahead and take a look at show IP BGP, and we could go ahead and again it says, okay, there are two available paths and the best path is number 2 at the moment. And the best path is, you could see that over here, and the best path is VI or ISP1. So that means in this mechanism, what is happening currently, that router R2 is preferring the routes or the path from eBGP versus the path from the iBGP. And that's what is happening at the moment. Now we want to go ahead and influence the path selection in such a way that we want our R2 to prefer the routes that it is learning from R1 instead of the route that is receiving directly from the ISP1. It could be because of many reasons. Again, as we discussed early on, let's say the link between router R2 and ISP1 is only, let's say, 100 Mbps link. But the link between router R1 and ISP1 is a gig link. And internally between these router R1 and R2, the links again are, could be a gig or it could be a 10 gig links. So there are many reasons, where you want to go ahead and prefer one path over the other. So in the previous demonstration, we went ahead and influenced the route selection with the help of weight. In this demonstration, we plan to go ahead and make use of the local preference. So if you take a look at the moment, the local preference being set as 100 here, which is the default again. So now we will go ahead and change the local preference for any route that we receive from router R1. So that means we will go ahead and say that, okay, hey, we will go ahead and change the preference of our router R1 because we are interested in preferring the prefixes which we are receiving from R1 over any of our eBGP neighbor. So we'll go ahead and change the local preference to a higher value for all the routes that are received from the external neighbor on router R1. And let's go ahead and see how we can go ahead and do that. So let's go to router R1. And on router R1, if I do a show IP BGP table, you could see, okay, hey, it is receiving some of these routes at the moment. And you could take a look at the local preference is anyway 100, the default. Now let's go ahead and change the local preference here. And again, if you, okay, let me go ahead and keep our old output just for comparison, show IP BGP. Let's go back to router R1. Now router R1 is again within the same AS, so the BGP process is again name 1. Now if you take a look at, there are quite a few commands, and one of the basic commands says BGP specific command. So now let's take a look at what are the BGP specific commands. So if you take a look at, there are quite a lot of commands that, we can go ahead and play around. And one of the command that we are interested into is a default, configure BGP default. So we are trying to change the BGP's default, some of the default. And again, we had learned previously, majority of the time, the defaults are good. You don't have to really change them, but there are certain scenarios like the one where we are trying to influence our route decision with the help of local preference. So we'll go ahead and change some of those default parameters. So we'll go ahead and use a default keyword here. And after default keyword, there are quite a few things that we can go ahead and change that. And one of the things we are interested in playing is the local preference. So what it really is the local preference, the higher is more preferred. So the higher the local preference, the more would be the preferred, this would be the, the router, will be for the preferred routes basically. So now let's go ahead and change the local preference, and let's go ahead and change the local preference. You could see this is a pretty large value. So let's go ahead and change the local preference to 150. And we could go ahead and end the configuration. That's all pretty much. Now, if we go back to router R2, because router R1 is neighbor with router R2. So now let's go back to router R2. And this is our previous output before we configured things. And you could see that from 12.1, when we were receiving the things, the default local preference was of 100. Now we went ahead and changed that to a higher value. And when we were doing the configuration, we saw that it clearly says the higher is equals to more preferred. So that means this would be a more preferred path or route, via this particular device. Now let's go ahead and take a look at our BGP table after that change on the router R2. And before this change, you could see we were learning this prefix from iBGP, but still the best path via the eBGP. Now let's go ahead and rerun the same command, show IP BGP. And now you could take a see here that our local preference has changed from 100 to 150. And with that, now you could see that our best and as well as valid and best path now is via our router R1. So we went ahead and influenced our route selection on our router R2, because what we said that, okay, I will go ahead and any routes that we are learning from, any route that the router R1 will learn, it'll go ahead and change the preference for those local routes or for all those routes to 150. And when it is advertising those prefixes to its internal iBGP neighbor, it'll go ahead and send these route with the higher preference. Now, when router 2 receives multiple paths for the same prefix, during the decision-making process, it will go ahead and do all that comparison. Now we are not playing any other parameter. It takes a look at, hey, okay, I am receiving a prefix via two paths, but I see one of the path has a higher local preference. So that means this is a preferred path, means this is the path which has higher confidence, and other things. So in that case, now our R2 will go ahead and pick this path over the path that it is receiving directly from the eBGP neighbor. So that's how we can go ahead, and change some of these parameters again with the help of the local prefix. Now we could go ahead and take a look at the same prefix that we were receiving, and now you could see again it continues to say, hey, there are two paths, but now in our best path is via path 1, and you could see again the best path is received from 12.1, which is our router R1, which is our iBGP router, and you could see again the local preference is 150 for this particular router. So hopefully you got the idea what we went ahead and did. So before we configured the local preference, the default local preference of 100, and sometimes it is not even C. So the local preference 100 was configured. Now, in the case router 2 was receiving the same prefix from both router R1, which is in iBGP, as well as from the ISP1, which is eBGP session. And we wanted to take the path, instead of going directly towards ISP, we wanted to traverse this path via the router R1. So what we did, we went to router R1 and we said, okay, hey, any routes that the router R1 is receiving from the external neighbor, we want to go ahead and change the default local preference from 100 to 150. And once we did that, now once the routes are received from the external neighbor on R1, and when R1 is advertising this, it's to internal neighbor R2, it sees, okay, hey, these are the routes with the higher preference instead of a default preference. And because of that, router R2 is installing that as a best and valid path to reach that particular IP prefix. And this is another mechanism that we can go ahead and employ for the the BGP route influence. So that's how we can go ahead and influence the BGP route selection mechanism kind of. So hopefully you get the idea that we can go ahead and have another attribute that we can go ahead and change on BGP. That'll be all for this demonstration. I will see you guys in next. Thank you.